All right, welcome to chapter 24-3, the esophagus. This will be a really short section. The esophagus begins at bony level C6, approximately, just inferior to the larynx, and enters the abdomen via the esophageal hiatus. This is at about bony level T7. I'm actually going to open up complete anatomy here. This is the thing that I've been using to make some of those in-class videos. And right here we're looking at the skeleton, and what I've done is I've added some musculature so that I can highlight the respiratory diaphragm, which is highlighted in yellow here. And then I've also turned on the digestive system so that we're looking at the digestive system. Here, if I zoom in, we have our respiratory diaphragm. I'm going to move to a more superior view. And here you can see this hole that's in the middle of the respiratory diaphragm. This is actually part of the central tendon, and we have 6 things that pass through this, so it mostly like arteries and nerves and such, but the esophagus is actually going to be posterior to that. So I have that highlighted, and that'll run just along the anterior portion of the vertebral column. And then if I remove the respiratory diaphragm, and I, again, look down the superior aspect of it, you could see how the esophagus dumps straight into the stomach, right at the beginning ends of the stomach, and we have the liver covering just the top portion of the stomach. All right, so histology for the esophagus is relatively simple. Again, we're going to have those 4 regular layers that we'd have for any part of the digestive system. So starting with the deepest, we'll have the mucosal layer. We'll have stratified squamous epithelium here and a lot of large folds to allow for accommodating really large portions of bolus. Then we'll have the submucosal. The submucosa will also be a large fold. And we'll have some glands here to make more mucus to allow things to be lubricated as they go down the tube. And then we'll have the muscular layer. And the muscular layer is one of the more interesting pieces of the esophagus because it's cut up into thirds. And what we mean by this is each third is a different type of a different type of muscle. So the top the top third is going to be skeletal muscle versus the bottom third is going to be smooth muscle. Wow. And the middle third is going to be a blend between mixed and smooth. And why is this? Well, if you forcefully try to swallow, you're able to do that, right? And you're able to push some bolus towards the back of the oropharynx and actually start beginning those propulsions and beginning the peristalsis down the esophagus. So you're doing that with the top 1/3. But after a certain period of time, you have no control over it. It's going down regardless of what you want it to do. And that's really the divider between the top 1/3 and the middle 1/3. The top 1/3 also, if we were to do it cross-section of the top 1/3, it would look like what's in this picture over here on the left. And it's actually, it's closed. It's sealed off. This is because we're trying to prevent any air from actually coming into the esophagus. Focus on breathing, let air move down the trachea. Don't put any air into the esophagus. We don't want a lot of air in the stomach. That would be bad news bears. And I also want you to appreciate the the skeletal muscle in here. It's kind of folded in on itself. It's waiting for bolus to come in, and it's relatively flimsy looking, which is typically true of the esophagus. If you had the chance to look at that in the cats, you can kind of feel how mushy the esophagus is, even though it's made out of muscle. It definitely does not have as much structure as the trachea does. Now, how do we control this esophagus? Parasympathetics and sympathetics. This is all going to be activated via the esophageal plexus. At rest, superior third, will be sealed off, and the inferior 1/3 was also going to be sealed off. So if we draw our stomach here at the end, a J-shaped organ, there's actually something called a sphincter right at the end, and this is, it's not a true sphincter, but it operates similarly to a sphincter. True sphincter would mean that there's actually a band of muscular tissue that's there to help cinch it off and open and close. This is a pseudosphincter, so the musculature kind of allows for it to close, but it's not very good at closing. And we call this the esophageal sphincter. formerly called the cardiac sphincter. And the esophageal sphincter is going to typically be closed so that it doesn't allow any of the building up of acid in the stomach to actually come up the esophagus. That is something known as heartburn or gastric reflux, or it'll be sensed as heartburn, but it's actually gastric reflux. The verb for swallowing is degluttination. This might sound familiar to one of the 7, I think they're sins, gluttony, and so that's where that word comes from. And in order to actually start the swallowing process, there are a couple things that have to happen. You have to be able to elevate the palatal muscles on the soft palate. So these are those perpendicular muscles that I talked about that actually whenever you open and you begin the swallowing process, they open the most medial portions of the auditory canal to allow for the pressure of the air from the external environment to match the internal environment, and so that's why you get that popping sound. So those muscles are going to elevate the soft palate while also doing that. Then we're going to have the palatopharyngeus muscle and then stylopharyngeus muscle elevate the larynx. These are some really small but very strong muscles that are in the posterior aspect of the larynx that you can't really quite see on any of the models that we have in class. Then we also have the epiglottis. The epiglottis is going to have to bend over the glottis so that we make sure that food is actually moving to the esophagus and not going down the trachea. And then we have pharyngeal constrictor muscles to help push the bolus towards the towards the esophagus. These are, again, small, but they're not as directional as palatopharyngeus or stylopharyngeus muscles. Then we have 3 phases whenever it comes to swallowing. The first is going to be the buccal phase. Buccal, named after the cheek or the buccinator muscle. And this is where we have the food within the cheek cavity or within the space. And we're holding the food within the oral cavity, breaking it up with mastication, and churning and making an actual bolus. Then the bolus hits the oropharynx and becomes then transitions into the pharyngeal phase, where it's not quite in the esophagus yet, but it's getting there. Then we enter in the esophageal phase, where the bolus is actually descending down the esophagus via peristalsis, and then the stomach phase, where we actually finally get food down into the stomach. Swallowing is a reflex. Like I said, the superior 1/3 portion you have some control over, but for the majority of the esophagus, it's going to be a reflexive response, which is good because we want that to be reflexive so that we have continuous peristalsis and continuous moving down of the bolus and any of the excess leftovers into the stomach. It'll begin with the palatal arches. So these are those, let me go back to that slide, those palatal arches that I showed in a couple different slides, where the uvula is sandwiched in between the two. And as soon as food passes over that will stimulate some of the receptors in the esophageal plexus to promote swallowing. The medulla oblongata is going to be what directs that esophageal plexus, and some of the cranial nerves are also involved in making sure food is moving down the esophagus. You'll have first a set of primary peristaltic waves, which is really important to get the bigger portions of the bolus down the esophagus. But then you might even have a series of secondary peristaltic waves. You can kind of picture this as you're swallowing a piece of cake, and the bigger portions of the cake pass down the throat, but then you have some breadcrumbs left behind. Well, you don't want those breadcrumbs left behind so that A, you don't get any nutrition out of them, but B, so that they also don't irritate the esophagus. So another set of peristaltic contractions are going to swiftly move all of those foodstuffs down into the stomach.